Okay, here is our practice exam. Now, I included this exam as a PDF in a previous post. So here I'm going to work through the exam as good practice. We'll see, maybe I'll break this up into 2 videos, not exactly sure yet, but these first 4 questions deal with metric conversions. Metric conversions are pretty easy because they're all about shifting the decimal one way or the other. Okay, and if you know your metric prefixes, it's really easy. Okay, maybe I'll squeeze them in here. This is something you need to memorize. Okay, kilo, hecto, deca. Okay, and then our base unit, and then deci, centi, and milli. Okay, that's our standard range that we need to know. And of course goes far beyond in each direction, but those are the base ones that we need to know. So we want to go from centiliter to milliliter. Centi to milli, 1 decimal shift to the right. So I'm going to have 25.4 milliliters if I have 2.54 centiliters. Okay, decigrams to kilograms. So deci up to kilo is 1, 2, 3, 4 decimal shifts to the left. So I'm going to take this and move it 4 places to the left. So I'm going to need 2 leading zeros, 8, 3, 9, and that's going to be kilograms. Okay. Hectometers to centimeters. Hecto to centi. 1, 2, 3, 4 places to the right. So now I got to move that decimal 4 places to the right. So I'm going to have to put in a couple of zeros there. Centimeters. Okay, by the way, if you think I make a mistake on anything, whether it be on this exam or any of those previous problems that I worked, please let me know. I'm not watching these videos and double checking everything. I'm kind of doing it on the fly just like I would be in class. And sometimes you catch mistakes in class. So by all means, if you see something that you think is wrong, let me know. Number 4, decaliters to deciliters. So deca to deci is 2 places to the right. So that'll be 0.4 deciliters. Okay? So metric is pretty simple, but you need to know all of these prefixes. Okay, now there's more prefixes beyond on either side. I don't expect you to know those. Just this, from kilo down to milli, and how to convert between the two. Okay? English units. You need to know a bunch of those also. Okay, and let me quickly refer back to the book here. If you look at section 4.1, okay, you need to know, you're expected to know a lot of these conversions, okay? On page 158, these inches to feet to yards to miles, all those basic length conversions you need to know. On 159, the ounces to pounds and the pounds to tons. And then teaspoons, ounces, cups, pints, quarts, gallons, all that stuff. Those are all measurements you need to know. Okay, I will not be providing any of those conversions for you. Okay, so you need to know those. So we need to go feet to miles. Okay, and again, for purposes of today, I'll pull out the conversion just to say here it is, but again, something we need to know. Now, feet to miles, we have that unit conversion. 5,280 feet is 1 mile. So I'm going to say 2876 feet. I'll give it a denominator of 1, and I'm going to multiply it by something. I want miles on the top, and I want feet on the bottom so that my feet cancel. 5,280 feet in 1 mile, so I'm going to write it like that. So I need to do this number crunching of 2876 divided by 5280. Okay, now on a problem like this, if I don't specifically say where to round, just give me a couple of decimal points. Okay, so 0.545. Again, what unit is left here? Miles. Okay, for that one. Problem number 6. tons to pounds. Okay, we need to know the conversion from tons to pounds. There are 2,000 pounds in 1 ton, so 38.2 tons. Give that a denominator of 1. I want the pounds to be on top and the tons to be on the bottom so that my unit of tons cancels. So in this case, I'm taking 38.2 and I am multiplying it by 2,000. And I'm going to get 76,400 pounds. Okay, so far so good. Now the next one, cups to gallons. You can remember a cups to gallons if you want, but that's not too common to go cups directly to gallons like that. However, we can go cups to quarts and then quarts to gallons, right? There's 4 cups in a quart, so I'm going to have 27 cups over 1, and I will say there are 4 cups in 1 quart, so the cups cancel, but now I'm going to have quarts, but I want gallons, so I'm going to say there are 4 quarts in 1 gallon. Okay? And then the quarts cancel. So the only unit left is gallons. So in this case, I'm really dividing by 4 twice. So it's going to be 27 divided by 4 and then divided by 4 again. Okay, 1.6875 gallons. Alrighty there. Pints to quarts. What's the relationship between pints to quarts? 2 pints equals 1 quart, right? Well, look at that. I'm asking you. Pints to quarts, right there. 2 pints over 1. What's the relationship? 1 quart to 2 pints. I'm giving you the conversion right there, aren't I? So 2 quarts. Okay, that's almost a freebie, but even the freebies you can make a mistake if you're not prepared. Excuse me. Okay. If we're going between English and metric, I do not expect you to memorize those conversions, but you need to be able to use conversions that are provided. So let's go from liters to quarts. 27.4 liters over 1. I'm going to multiply that by this conversion factor, but I have to figure out which way to put it. I want the quarts on top, and I want the liters on the bottom because I want liters to cancel and I want to be left with quarts. 27.4 times 1.0567 equals 28 point, again, we can maybe round that off here, 953, whatever, I'll just leave it. 95358, what unit are we talking about? The unit of quarts. Centimeters to inches. 27.6 centimeters. Give it a denominator of 1 and multiply by this, and I need to figure out which way to go. I want inches on top, and I want centimeters on the bottom, so the centimeters cancel. So I'm going to take 27.6 times 0.3937 equals 10.8, this one I will round, 10.87 inches. Okay, there we go for that one. Yards to meters. Yards to meters. 38.6 yards. Give it a denominator of 1. Multiply it by this unit ratio. Figure out which way I need to go. 1 meter over 1.0936 yards. Because I want the yards to cancel. That's how we know which way to put it. One unit's going to cancel away, the other unit's going to remain. Okay, when I run the calculation here, what do I get? 35.296 meters. Alright, so far so good. Now Number 12, convert degrees Fahrenheit to Celsius. Now this is not a one-step process, okay? It's not a what we call a direct variation, or directly or inversely proportional, we may call it, or there's a little more to the story here, okay? This is classic linear equation that we're going to talk about after our next exam. Okay, so what are we going to do here? Right now we're going to plug some numbers in. I know what the Fahrenheit number is. I'm trying to calculate the centigrade or the Celsius number. So I'm just going to put the information in. 5/9 times 40 minus 32. Okay, I just have to figure out what this is. So that's 5/9. 40 minus 32 is 8. So I know 8 times 5 is 40, so 40 divided by 9, I'll get some kind of decimal here. What will I get? Repeating decimal, so 4.4 repeating would be our Celsius temperature. Okay? If we start with Celsius and we want to go to Fahrenheit, it's a little bit different formula given here. Now I really didn't need to put a parentheses around that Celsius like I did there. I had to have them up here, but I don't really need a parentheses here. So if you see it without the parentheses, it's okay in this case. So degrees Fahrenheit equals 9/5 times my degree Celsius, which is 150. And then I add 32 after that, okay? So what is that going to give me? I got 150 times 9 divided by 5, that's 270. And then I'm going to add 32 to it. That's going to give me 302 degrees. So yeah, that's hot, okay? Remember, the boiling point of water in the Celsius scale is 100, so I'm well past the boiling point of water. And in the Fahrenheit scale, we know the boiling point of water is 212. Okay, precision. When I'm taking a measurement, the precision can only be to the unit of increment in the measurement. Okay, so in other words, I have 5 1/3 inches for some measurement here. Well, my precision of scale there can only be this fraction of a third. Okay, so my precision in this case is only 1/3, the smallest increment. Now it was given to us as 5 1/3. It could have been 5 2/3. Okay, but my precision would still be just a third. It's the smallest increment. Okay, third is my smallest increment, so 1/3 is my smallest level of precision. How about this one? If it's in a decimal, my smallest increment is way over here to the right there. So what is that? That's a tenth, a hundredth, a thousandth. Okay, I should indicate units here. So at 1/3 of an inch is my greatest amount of precision there, and 1/1000th of a meter is my greatest level of precision there. Okay. Error is half of the precision. Error is half of the precision. So if I wanted to find precision here, it would be 1/4. So the error is half of that, so it would be 1/8. Okay, we're being asked to find the error here. So the error is 1/8. The precision here is 0.01, 1/100, so the error is 0.005, half of it. Okay, again, centimeters here and inches here. Okay, precision is just my smallest increment. So if it's a fraction, it's the smallest fraction of whatever the denominator is. Again, I gave you 1/4 here. This could have easily said 3/4, and it's still going to be a precision of 1/4. And in the decimal form, it's just going to be my smallest increment here. In this case, the hundredths position. So 1/100th would be my level of precision, and the error would be half of those, 1/8 and 5 1/1000, which is 1/5 5 over 1,000. Okay? All good there? Sweet. Determine the number of significant digits. Okay, remember the rules here. All non-zero numbers are significant. If it's a whole number without a decimal, then trailing zeros are not significant. Okay, if I have a number where zeros are captive between two non-zero numbers, then those captive zeros are significant. If I have a decimal number where it's 0 point something something, any leading zeros would not be significant. Okay, so this first one, I have no zeros at all, so I can just say all 6 of those non-zero numbers are significant, so 6 significant digits. Here I've got 32,000, but no decimal point, nothing after a decimal point, so these trailing zeros are not significant. So there's only 32 there, or only 2 significant numbers, significant digits. Here I have some captive zeros, so all 4 of those are significant. Here I've got a decimal, however, it's a 0 point something, and leading zeros are not going to be significant in that case, so I only have 1. Here I've got a number with a decimal point, and trailing zeros after the decimal point are significant, so that's going to be 3. Okay, number 21 here, had it been, 4.008, now those are captive zeros once again, so that's going to be 4 levels of precision. Okay, 4 significant digits. Alright, so there'll be a few questions there. All of these are now going to be extremely similar to the real exam. And I'll do one more, and then let me see, I'm at 17 minutes already. How time flies. Yeah, maybe I'll stop it here.